Hi guys, good morning. Hope you're all doing good. Okay, so I am saying almost more than 10 participants, right? So we are almost past 10, 4 more minutes. In 4 minutes past time, I think we'll start. Guys, I wanted to know in your book, in your CBSE textbook, which is the chapter number for chemical reactions and equations? Anybody knows?
First chapter, sir.
First chapter. Okay, fine. Let me. Okay, cool. Downloads. Okay, fine. Downloaded it. Maybe. Cool. So fine, guys. I think I'll share my screen right away. And then we'll start. A little late today. Sorry about that. And yeah, and regarding your assignments, let me check. So I got. Let me tell who on all submitted. So today morning, I got. I don't know what the name is. Akshita. Akshita submitted. Amrita submitted. Arman submitted. Before that, some people have submitted. Fuja, Durlav, and Harita. So other than that, I think I didn't get anybody else. Did I miss anybody, guys? You submitted and I didn't tell your name. Is there anybody like that?
Sir, I submitted, sir, Vaishnavi.
Vaishnavi? Okay, fine. I'll check. Fine. So guys, whomever didn't submit, I told you that you shouldn't be attending the class. I'm giving you just one more day. Today is the last day, right? I want everybody whoever didn't submit, please submit it. I almost got all of it, right? Very few of you didn't submit, right? So please do not delay it. Again, it's not for my thing, right? I'm really not going to get benefited from this. It is you who are going to be benefited, right? So today is the last day for submitting. Whomever didn't submit, please submit it, and please don't copy. Like even if you did 1,000 wrong answers, I don't mind, right? But it's all about trying there. Should I send PDF? You can send it in PDF format or pics if you have. I'm fine with it, right? But if you can, there is something called as Adobe Scan. I don't know whether you know it, right? There's something called as Adobe Scan. So in that Adobe Scan, you can convert it into PDF. Can I submit now? Yeah, you can submit now. No issues. Aditi. Right. Okay, fine. So let us start. Let me share my screen. Okay. So guys, you wanted to teach me, you want me to teach you about this, what is that? Activities, right? So that's why I had to download the books. So let me, yeah. So let me do that. Okay. So maybe if I can zoom it. Yeah, guys, is this visible now for you? Everybody?
Yes, sir.
Okay,
Yes, sir.
cool. Fine. So they said that there are 11 activities. Let me see what all is there. It's going to be very easy only. Okay, fine. So the first activity, right? So the first activity, guys, you're able to see my cursor, correct? This, whatever is moving, you're able to see that?
Yes, sir.
Okay, cool. Right. So here, this is the magnesium ribbons thing we have been doing, right? So I said, right, you have to take the magnesium ribbon and then you have to rub it with sandpaper. Do you know why are you rubbing the sandpaper? right, is because there'll be some coating of oxide or sulfide on the magnesium ribbon, right? So to remove those things, so I use sandpaper, right? And these things you say as tongs. Tongs are nothing but this, like a scissor. Like how do you hold it? That is what is called as a tong. Okay, right? And then obviously you will have a burner, or they call it as a lamp, or you can just use a burner, normal stove burner you can use, right? And then you will burn the magnesium ribbon, right? And I told you that this magnesium ribbon is going to burn with something called that. I don't know whether I can write here. Can I write? No, I cannot write. Guys, one second. Let me see if I can write it. One second. If I can, one second, guys. Just give me a moment, okay? I will download this onto OneNote, and then it will be easy. So, file. Set up a printer. Okay, great. Okay. Now I'll be able to write on this. Right, fine. So I hope, yeah, yes, tell me. Is there any problem, Kana? Okay, fine. I hope there's no problem. Fine. So fine, they said that they have to burn the magnesium ribbon for keeping it away, right? So what is the order? How do you observe? You observe that here. You observe here that I'm going to have dazzling white flame, right? The magnesium ribbon burns with the what is that? A dazzling white flame. And then the ash you collect. See, they're collecting the ash here, right? They're collecting the ash here. You see, right? So that ash will be white in color, and that ash is nothing but MgO, magnesium oxide. Okay, and hope you all remember the reaction. The reaction is Mg plus O2 giving MgO, and you have to use the symbol delta. Now this delta represents what, guys?
Heat.
Heat. Correct. This delta represents heat. You have to heat magnesium in the presence of oxygen to form MgO. And what do you observe? You observe that the magnesium burns with a dazzling white flame. That is exactly what you observe. Okay, and the ash which you collect will be white in color, right? And then that will be magnesium oxide. It is given here, magnesium oxide, MgO, right? That's the first activity. Cool. Next. Cool. Now look at this. They are taking lead nitrate. Take lead nitrate solution in a test tube. Add potassium iodide to this. What do you observe? Right. Now this is again a very simple thing. We have seen the reaction. Right. Now where do I have space? I have some space. Okay. I'll write it here. Okay. So they are telling that they are taking lead nitrate. Lead nitrate is PbNO3. Right. And then they are taking potassium iodide. Okay. Now, okay, first tell me what kind of reaction is going to happen. We saw about different kinds of reaction, right? What kind of reaction do you expect to happen here?
Sir, displacement reaction.
Just displacement?
The double displacement.
Double displacement. Now, you know, whenever you see like this kind of stuff, two salts are used, potassium nitrate, you had positive ion, negative ion, positive ion, negative ion. Whenever you see this kind of stuff will happen, right? You will understand that it is always going to be double displacement. And whenever double displacement happens, the cation and the anion both get exchanged, right? So here, what will you form? You will basically form potassium. Here you see potassium iodide and lead nitrate. So in the product side, you will see that I'm going to have lead iodide. That is, iodide is going to go along with lead, and potassium is going to get the nitrate ion. Okay, and writing the formulas are very important, people. Hope you like. Okay, tell me what will be the formula for lead iodide? Lead iodide formula, Pb. PV, that's it.
PBI, sir.
Okay, first, what ion lead forms? What ion lead forms? What positive ion?
2.
Pb 2 plus, correct? Right. So I told you, but this lead, barium, and zinc, all of them you will not be able to do it properly, but you have to remember that all of them will form +2 ions. You have to remember this, all these people, or else writing formulas will be very, very difficult. Okay, fine. Next, iodide will form what ion? Iodine will form what ion? Basically, iodide, what is the formula? What ion it will form?
I minus.
I minus. So remember, iodine, I told you, remember the group, right? It comes under fluorine family. F minus, Br minus, Cl minus, I minus, all of them will form the same ion, right? So now you can easily understand that if I can write it here, I have Pb2 plus, I minus, no, this will come. So what will be the formula? Formula would be Pbi2, right? 2 will come there, 1 will come here. Pb2 plus, I minus. Done. PbI2. Okay, what is nitrate ion formula? What is nitrate ion?
NO3 2 minus.
NO3 2 minus. Okay, actually I wrote it wrong here, guys. I'm sorry. This is PbNO3 twice. Maybe if you would have told with this, I'm really sorry. It is NO3 minus nitrate. Right? Nitrite is NO2 minus. This is nitrate, ATE. Right? This is IP. Okay, NO3 minus is what is my nitrate ion. Okay, so now again I have basically K plus, right? I have K plus NO3 minus is what I have to form. So 1:1 only. So I can easily write that here. I'm going to have K NO potassium nitrate. Okay, I hope this equation is very clear, guys. I think you are not, maybe you are studying, but you are not studying about the formulas. We spend so much time on the ions, how to write the formulas and stuff initially. Please do go through all that, right? Even though you know what is going to happen, now what do you observe? All these questions you will be able to answer. But if you're not able to write the equation, there's no point in it. Okay, I think there is some chat here. Oops. Sorry. Why did I? Okay, right. So there's no point in knowing whatever it is without writing the equation. This is how you write the equation. You have to remember all the ions so that you will be able to write the formulas. Okay, now this is the equation. So they're asking, what do I observe? Right. Now, please understand, people. Can you tell me what is going to happen here? Any idea? We spoke about this particular reaction, but in maybe in terms of NaI, instead of K, I would have had put sodium. Instead of potassium, I would have put sodium in the equation. Right. And I told you something is going to happen here. What is going to happen? If you just go through the notes which you have taken, you will be able to answer this question. Maybe in place of nitrate, I would have put something else. But there is something special about this PbI2. What is special about this PbI2?
Precipitate, yellow color precipitate.
Correct. Right. So this is going to be a precipitate. I put a downward arrow. Downward arrow. Hope you all remember that it is going to be a precipitate, and this will be yellow in color. Right. Yellow color precipitate. That is what is going to happen. Right. So what do you observe here? You will observe that the solution, right? You would have lead nitrate, potassium iodide, both are white in color. Right. These solutions are basically colorless or white in color, you can say. Right, these are normal, like how you have normal, if you put salt in water, how it will be normal salt in water. That is how it will be, colorless solutions, right? So this colorless solutions are going to become an yellow precipitate because of the formation of PbI2. Okay, right? So that is about activity 1.2. I hope everybody understood. It's very easy. Okay, next. Fine. Next is activity 1.3, which is say that they have to take us a few zinc granules. Basically, zinc is what you have to take. Now, remember, every metal will be in different forms. So, if you take magnesium, it will be in form of ribbon. Zinc granules make a tablet. Okay, how do you have tablets like that? You will have zinc in the form of that. Okay. Now they're telling that you have to take zinc granules. I'm sorry, guys. I think there was a network issue. That's why I just, I don't know. I think I was taken out of the meeting. So we'll continue. Right. Okay. Again, I have to make them. Okay, I'm lost. A lot of problems today. Right. Okay. So what I was telling is, yes, we're talking about, guys, you're able to hear me and you're able to see the screen. Everything is okay.
Yes,
Yes,
sir.
Yes, sir.
Okay, fine, right. So I told you that I have to take what is that conical flask, in that you put zinc granules. Zinc granules are nothing but zinc in the form of a tablet, like that's what they call granules. Okay, so to that you have to add dilute sulfuric acid. Okay, and then what to say, this is going to be closed. Okay, this is going to be closed with the help of a cork, right? It's like a stopper, something like that. Okay, and then through this, right, through this you will be able to what to say, some gas, if it is going to evolve, it is going to come out of this tube, whatever is here, like that small cylindrical thing you're seeing. It's like a tube, and through that you're going to get out the gas. That's what is going to happen. Okay. Now, first thing, before we understand before we try to answer these questions, right? What do you observe? Anything around zinc granules? That's the conical flask. Is there any change in temperature? All this we'll answer. But first, what you have to understand is what is the reaction here? Okay, guys. So remember this: whenever a metal, right? Whenever you will see again this in the next chapter, acid, bases, and salts. Please remember this: that whenever a metal reacts with acid, okay, whenever a metal reacts with acid, you will always form salt, and H2 gas will be evolved. And this you have to remember. It's very easy, right? When you look at the equations, it's going to be very simple. Okay, so remember that whenever a metal reacts with an acid, you are going to form a salt, and you're going to evolve H2 gas. Again, gas evolution, I told you, on the product side, if it comes, I have to put an upward arrow. Okay, now see, you look at what is happening here. You have zinc, which is a metal, right? And you have dilute sulfuric acid, right? So you have zinc plus formula for sulfuric acid. Sulfuric acid formula. Sulfuric acid formula. Really? Hydrochloric acid?
HCl. Sir,
Okay.
H2SO4.
H2SO.
Thank you. Correct. Nitric acid?
Sir, is it
Nitric acid?
HN3, sir?
Yeah. Please remember, these three acids are very important, guys. HCl is hydrochloric acid. H2SO4 is sulfuric acid. HNO3 is nitric acid. Okay, so all these things you have to remember. Okay, these are all common acids we use in our chemistry labs. Okay, we'll study more about them when we go to the next chapter. But for now, you have to remember the names and the formula. Okay, so you can understand hydrochloric means chlorine will come. Sulfuric means sulfate will come. Nitric means nitrate ion will come. NO3 minus will come. NO3 minus H plus. SO4 minus H plus. Cl minus H plus. That is what is going to be there. Okay, so in this particular case, they are taking dilute sulfuric acid, right? So sulfuric acid, we know it is H2SO4. Okay, guys, even though you don't remember this particular statement, that is whenever a metal and an acid is going to react, I'm telling you that I'm going to form a salt and hydrogen. Even though you don't know this, you will be able to answer this question. First, tell me what kind of reaction is going to happen here, right? Looking at the zinc plus H2SO4, what do you think? What kind of reaction is going to happen? You do not know the product, but all I'm asking is you have different types of reaction, right? Combination, decomposition, displacement, double displacement. Here, what do you expect to happen?
So
Sir,
displacement
salt
reaction.
plus hydrogen.
Yeah, salt plus hydrogen will be there. What I'm asking is what type of reaction it is?
So displacement
sir.
reaction.
Displacement reaction. You see, this is a metal. Again, hydrogen will be a metal. Correct. So this zinc is going to replace hydrogen. That is what is going to happen. And that is how you form the salt. Basically, a salt you are going to form. Okay. Now, just you do not know the formula, but can you tell me the name of the salt form here? Looking at the reaction, now that you know it is displacement reaction, right? So can you tell me the name of the salt?
So
Zinc
Zinc
sulfate.
sulfate.
Zinc sulfate. Absolutely. Because I understand here that it is sulfate ion, right? SO4 minus is what is made. What is there? And obviously zinc is there. They are going to combine together to form zinc sulfate. Okay, fine. Now that you know it is zinc sulfate, can you tell me the formula for zinc sulfate? Zinc forms what ion?
2 plus.
Zinc 2 plus. That's now we said lead, zinc, and barium. All of them will form 2 plus. Okay. Now just now I told you what is the formula for sulfate ion?
Say SO4
SO4?
minus.
SO4 2 minus. That's what I have, and I have Zn2 plus. So what is the formula now?
ZnSO4.
That's it. Done. So because 2, you can put this 2, but 2 will get cancelled. Right? So you are going to form zinc sulfate. And basically, for example, guys, instead of this H2, say if I had aluminium here, right? What would have happened? I would have directly wrote aluminium, right? But like that, can I just write H here? Like because I have hydrogen here. Again, I repeat. If I had instead of hydrogen sulfate, we can even call it hydrogen sulfate. Basically, it is H2SO4 sulfuric acid. Okay, so now I'm going to have displacement reaction. Zinc is going to displace this and hydrogen is going to come out, right? If it was aluminum sulfate, I would have just write Al, that's it, right? But like that, can I write just H?
No, sir.
No, sir.
What should I write there? What should I write?
H2.
H2. It's because you have to always write how the element exists in nature. Aluminium exists in aluminium, that is a monoatomic form. We already discussed this, right? But hydrogen, oxygen, chlorine, all these things will exist as exist in diatomic state, like twice H2, Cl2, O2, N2, like that. Okay. So, anyways, the overall thing what you have to understand is, I'll remove this part. Okay. So the overall thing what you have to understand is the overall reaction is zinc plus H2SO4 will form ZnSO4 plus H2. That's it. That's the reaction. Very, very simple. Right. Obviously, hydrogen gas will be evolved. And this hydrogen gas only, they are telling that it's coming here. Okay. Hydrogen gas evolved and it is going to come through the glass tube. They call it glass tube. You can see here the glass tube. Okay. Right. And that is going to come out. Okay. Now that we know the equation, right? This is the equation, right? Now we'll try to answer the question. Okay. Do you observe anything happening around the zinc granules? Yes, you will see that the zinc granules will try, say, I hope you're looking at my video. Okay, my face. Okay, so the zinc granule will be in the form of tablet, as I told you, right? It will be round color, round shape. Okay, now it will be there in the test tube. Now, the moment you add your any acid, not only H2SO4, any acid for that matter. Okay, so what will happen is this zinc granules will start disintegrating, in the sense that, like, say, I don't know whether you have noticed it. Say I have a paracetamol tablet. Okay, it will be solid form. It will be in a granule state. Now you put it in water. What will happen? They'll start disintegrating. Correct? They'll start dissolving in water. Eventually, you will not be able. You're not even able to see the tablet. Okay, that is exactly what will happen here, right? So the answer to this question, right? What do you observe? Anything happening around the zinc granules? Yes, the zinc granules are going to get disintegrated. The answer would be disintegrating. Disintegrating means basically what? Separating into smaller parts. That is what is going to happen, right? So that is happening to zinc granules. But if you look at the question properly, they are telling, what do you observe anything happening around the zinc granules? That is, surrounding the zinc granules, do you observe anything happening? Obviously, what will happen is the hydrogen gas is going to get evolved. So surrounding the granules, you will see that the vapors of H2 are going to come out. That is what you will see. Okay. So first thing is the zinc granules will disintegrate, and around the zinc granules, what you will see is that the hydrogen gas is going to get evolved. So you'll see vapors basically coming out. That's what will happen. Okay. Now, next question they're asking is, that's the conical flask or test tube. Is there any change in temperature? Okay. Now, what will you observe is that before adding the H2SO4, you will see that it is a normal temperature. If you touch this thing, it will not be hot, neither cold, room temperature, before adding this dilute sulfuric acid. But once you add the dilute sulfuric acid, okay, once you add the dilute sulfuric acid, and when the reaction starts, hydrogen gas gets produced, what will happen is that you will see that the test tube has become hot. Okay, the test tube has become hot. And why this happens? Can someone tell me why test tube is becoming hot?
Due to evolution of hydrogen.
Due to evolution of hydrogen? No. Because what kind of reaction it is? If so the test tube becomes hot, then what can you tell about the type of reaction? Not the displacement and stuff. There is one more type, right? The one more way in which you can classify.
Exothermic.
Absolutely right. So what you understand, if I observe that the solution, that the test tube is becoming hot, that means this is an exothermic chemical reaction. That is what you have to understand. Okay. So actually this whatever is there, you will be actually doing it in the lab. If you go to your school someday, right, you will be actually doing the zinc granules experiment in your labs. Okay, you have zinc granules, you add this thing and you touch it, it will be very hot, right? Before adding, it will be normal temperature, but after adding the dilute sulfuric acid, this would have become hot. Okay, and why it is becoming hot is because it is an exothermic chemical reaction, as simple as that, right? And we already discussed so much about endothermic and exothermic. There, in any reaction for that matter, you will have both heat absorbed as well as heat released, because I have to break bonds and I have to make the bonds, right? It is all about which is dominating, right? The energy absorbed is dominating, and energy absorbed is more, or energy released is more. If energy absorbed is more, then it is endothermic. If energy means heat, basically. Okay, when the heat released is more, then it is going to be exothermic. In this case, I find that it is going to be exothermic in nature. Okay, any questions, guys? Any question in all the three experiments and all the three activities which we saw? Any questions? Okay, I suppose there are no questions. Please feel free to ask any question. And like, it might be a stupid question for you, but it can turn out be a wonderful question. You don't know about it. I mean, unless and until you ask it, you don't know. Okay, I hope everything is clear. Right? Okay, fine. Now, what is the next activity? There is my activity. This is balancing. This is what we saw. Yeah, what is the activity? Okay. This is another thing.
Sir, I have a doubt, sir.
Yeah.
Sir, in the second activity, sir, sir, what is like potassium nitrate, sir? Is it like in solid form or?
So no. Okay, that's a very good question actually. So all of these are aqueous solutions. If I have to mention the states, if I have to write it properly, I have to put AQ here, AQ here, and here I'll put AQ. That is for potassium nitrate, I'll put AQ. But this will be a precipitate, yellow precipitate, right? All of them are salt solutions. I hope you know what is AQ. AQ means aqueous solution. This particular salt is dissolved in water. Only then we can write AQ. There are 4 states, if you can remember. Solids, we will put S. Liquids, we'll put L. Gas, we'll put G. And the 4th one is aqueous solution. For aqueous solution, we put AQ. And aqueous solution is nothing but anything dissolved in water is what is called as your aqueous solution. So PbNO3 will be aqueous solution. And this KNO3 will be aqueous solution. Ki will also be an aqueous solution except for PbI2. Okay, understood?
Yes, sir.
Okay, good. That's a very good question actually. Like, these kind of questions only you should ask. Like what is the state? How it will look, right? Because you are not visualizing it, right? Like I'm just telling you the equations. You can just look at the equation and maybe put in some imagination. But you don't exactly know how they will look and all unless until you do the experiment. Correct. So it's okay to ask these kind of questions. It's a good thing to ask these kind of questions. Fine. Moving on. Okay. Now look at this. Right. So, okay. Take a small amount of calcium oxide or quicklime. I think we talked about lime water. Correct? Lime water. What is lime water, guys? What is the formula? Lime water. This is not this one. This is not calcium oxide. Quicklime is different. Lime water, or it is also called as slaked lime. What is the formula? Where do you see this?
Sir,
Lime
calcium.
water.
Calcium.
Tell me.
Sir, calcium carbonate.
Calcium?
Hydroxide, sir.
Calcium hydroxide. Where do you see this lime water?
Sir, test
Where
for
did you-
carbon dioxide.
Correct. Test for carbon dioxide. Test for carbon dioxide is lime water turning milky. Right? Lime water is basically CaOH twice. That is calcium hydroxide. Hope you know how we got this formula. It is Ca2 plus and OH minus. Okay, right. So you have calcium hydroxide. Calcium hydroxide reacting with CO2. I am going to form calcium carbonate plus H2O. Right? And this solution will be a turbid solution, not fully dissolved. Calcium carbonate is only little dissolved in water. So I can even call it as a precipitate. Okay, so this milky or turbid is that is what is the test for CO2. Hope you all remember this equation. Okay, fine. This is not what we are going to do, but this is going to come. Like this CaOH is going to come. You can see here. Okay, what they're writing. Anyways, now look at this. They are taking some amount of calcium oxide or quicklime. Guys, you have to remember this. Calcium oxide is also called as quicklime. Quicklime, slaked lime, lime water. Right? Lime water and slaked lime are same. CaOH twice. Quicklime is CaO. Okay, calcium oxide. Okay, fine. Now they're telling slowly add water to this. Right? I have in a beaker, I have some calcium oxide. It should be in solid state. Okay, maybe if you look at the equation, it's very simple. Calcium oxide in solid state, right? You add H2O to this. Okay, now fine. You know the equation here. Your equation is here. Touch the beaker, right? Like we saw in the previous case, when I touched the beaker, I found that the beaker was hot. Where was it? Here I found that this was hot because it was an exothermic chemical reaction. Okay, right. Now in this case, touch the beaker and do you feel any change in temperature? The answer is yes. First thing is yes, you will feel temperature change. That is before adding water, after adding water. Before adding water, normal temperature or whatever the room temperature, you will be at normal heat. Okay, but after what to say? After this thing, what is that? After adding water, you will see that again this has become hot. Okay, this has become hot. Right? That's what is given here. You can see, right? CaO reacts with H2O to form calcium hydroxide plus a lot of amount of heat. This is heat is going to get generated. Again, if heat generated, the test tube will become hot. Okay, because again it is an exothermic chemical reaction. Okay, very simple. The equation is there. I'm not writing it. CaO, calcium oxide is quicklime. You add water to that. I'm going to form slaked lime. Right? Now, guys, remember this. Whenever you want to form a hydroxide, right? Whenever you want to form a hydroxide, calcium hydroxide, sodium hydroxide, magnesium hydroxide, whenever you want to form hydroxide, remember this. Whenever a metal oxide reacts with water, right? Whenever a metal oxide reacts with water, you are going to form metal hydroxide. Right? Remember this. Okay. Now there are reasons to this why this happens. Right? Metallic oxides is only basic in nature, but again, we don't have to go into the details. We'll again see all this when we go for second chapter, acid bases and salts. Okay, right. So metal oxides in general will react with water to form metal hydroxides. Okay, and that is, you can see here, this is happening. CaO is metal oxide, calcium is a metal. The oxide former is metal oxide reacting with water to form metal hydroxide. And yeah, some of them will be exothermic. And here in this case, you see that it is going to be exothermic because heat is going to get released and it is going to have increase in temperature. When you touch this thing, you will find that I'm going to have increase in temperature. Okay, right. Now tell me, okay, fine, this is okay. What is the type of reaction here, guys? Obviously exothermic. Other than that, what type of reaction it is?
Combination reaction.
Yes, absolutely right. You see two things, A and B combining together to form C. A plus B giving C. Two things combined together to form one thing. Whenever that happens, you can actually given here, it's a combination reaction. Okay, very simple. Right, moving on. I hope there are no questions. If there are any questions, please ask me. Right, okay, we talked about this, right? Calcium, carbon dioxide, like lime water turning milky. Okay, so that reaction is what is there. And then this CaCO3 is used for whitewashing. We say sunnambu, right? In Tamil, if at all, I don't know, I hope everybody knows Tamil here. Okay, so we say sunnambu, like basically before painting the house, right? Before painting the house, they'll give a coating of the sunnambu. Right, a white color substance they will paint, right? It's not a paint, this is basically calcium carbonate, and that's what they're telling here, right? Calcium carbonate is formed after 2 to 3 days of whitewashing. Okay, and give a shiny finish to the wall. Okay, and one more thing is calcium carbonate is also this marble, right? You go for marble flooring, you have tiles, right? Again, that can also be calcium carbonate. That's what is they're telling here. Right? Once you go through the book, you'll get a lot of information. The book is very good actually. Okay, fine. Next, okay. Did you know? Okay, look at this question, guys. Did you know that a respiration is an exothermic process? Do you know that?
Yes, sir.
Okay, how can you say sense it? How can you prove it to me?
Like energy gets like released, right?
Sorry. Yeah, energy get released, but how will you prove it? Nothing. Basically, when you
The glucose is broken down, sir.
that is digestion. We'll come to that. Okay, fine. Look at this, guys. It's very simple, right? You just keep your finger near your nose, right, and try to breathe. You will find that only hot air is coming out. That eventually means there is going to be an exothermic process. Very simple, as simple as I just asked you to prove. Proof. How will you prove? Just keep your finger and feel the hot air coming out, and eventually you understand that it is going to be an exothermic reaction. Okay, right? Fine. And then this you can read through. This is actually a very interesting thing which is given here. Maybe you will study more about it in biology. Okay, fine. Now remember, digestion is an endothermic process, right? But respiration is exothermic. Okay, you can remember this, and you can dig in more using Google, or if you look at it in biology, they'll give you like a lot of examples, a lot of insight about this. Go through it. Okay, fine. Next thing is, okay, activity 1.5. Now they're take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Boiling tube is nothing but a test tube, guys. This is a normal test tube. Okay. Now boiling tube, which will be a little more strong. That's it. A normal test tube will sometimes break if you just heat it. So boiling tube is a little more stronger test tube. Nothing. Okay, fine. So take 2 grams of this and note the color of the ferrous sulfate crystals. I forgot the color of the ferrous sulfate crystal, guys. I think it will be green in color. Actually, we'll check. 1 second. Yeah, what I told was right. It is green in color. Okay. Now note the color. So color of ferrous. Okay, first thing first. Right. Remember, iron can form 2 ions. Okay, there are very few things which can do this. Okay, iron can form Fe2 plus and iron can form Fe3 plus. Okay, 2 ions it can form. Like why it can form 2 ions? Again, you have to come to your 11th class or even 12th class. Only then you'll be able to understand how this exactly happens. Okay, so remember, whenever Fe2 plus ions are there, it is called ferrous ion. Ferrous. Ferrous. Whenever Fe3 plus is formed, that ion is called ferric ion. Okay, Fe2 plus is called ferrous ion, Fe2 plus, and Fe3 plus is called ferric ion. Okay, right. Now, iron is given, iron sulfate, basically ferrous sulfate. Can you tell me the formula? Looking at this, ferrous means it's Fe2 plus. Can you tell me the formula for iron sulfate? Sorry, ferrous sulfate.
Sir, FeSO4.
FeSO4.
A sulfate ion is SO4 2 minus, and I have Fe2 plus. So you'll swap. I think if you would have noted down, it's here. Ferrous sulfate is FeSO4. Okay, Fe2 plus SO4 2 minus. Remove this. If they have told ferric chloride, right? I'm telling, if I ask you, I have ferric chloride, what will be the formula? Ferric, FeCl. No, the voice is breaking. Can I FeCl what?
FeCl3.
Correct. FeCl3. Again, you can see easily it's Fe3 plus ferric. Just now I told you Fe3 plus And chloride ion, I know Cl minus. So you'll put Swift swap. So you'll find FeCl3 will be the formula for ferric chloride. Ferrous chloride will not, it is not there. Actually, FeCl2 doesn't exist. But anyways, right? So you have to remember the difference between ferrous and ferric. Ferrous is Fe2 plus, ferric is Fe3 plus. Okay, fine. Now what they're doing, so note the color of the crystal. The color of the crystal is green. Right? This iron sulfate which is here is green in color. Okay, right. Oh, that's mentioned. See, have you noticed the green color of Fe sulfate, ferrous sulfate crystal? Yes, we will observe it. Okay, fine. Now you see, they're heating it. Heat the boiling tube over the flame of a burner, right? And you have to observe a color change. Okay, now look at this, guys. This is the equation, right? You have one thing, right, getting separated into three stuff. Basically, even if it's going to be two stuff, more than one thing getting separated into many other stuff is what is made decomposition. That's why we're seeing it under decomposition reaction. Okay, now iron sulfate will, see, remember this, guys. Generally, whenever you have metal sulfates, right, and you heat it, okay, you will generally form metal oxide plus SO2 or SO3 and both, or either of the can form. Okay, now remember that metal sulfates, whenever you heat them, you are going to form metal oxide plus SO2 or SO3 or both. So both of them can come. Okay, right? And that's exactly what we're seeing here. Guys, like you might be thinking that, oh God, I have to bug up all these equations, but it is not like that. See, chemistry is a subject which has to be taught with experiments. Okay, we have to go to the chemistry lab. Then you don't have, like, even though you have to remember this, but the remembering will become more easier when we go to the chemistry labs and do all these experiments. But you know, our curriculum, our way of education is, I would say, bad, that you have to remember it like this. And the mistake is not yours, the mistake is not mine, the mistake is with the people who are making the policies. Okay, so please bear with it. Okay, I do understand that this is not the way you should be learning, right? But still, okay, fine. Anyways, so you're heating the ferrous sulfate crystals, and then you know the ferrous sulfate will be green in color, that is mentioned here. And then when you heat it, and again the heating symbol can also be this delta. I can even put delta. Okay, will form, I told you, a metal oxide, that is ferric oxide, Fe2O3. I think, oh, now you see, guys. Fine, okay, well, not actually, I don't want to confuse you. See, ferrous sulfate is becoming ferric oxide, right? I just now we spoke about ferrous and ferric, right? Ferrous is Fe2 plus, ferric is Fe3 plus, and that is why it is forming Fe2O3. Now, if you look at this, Fe3 plus, what ion oxygen forms? What ion oxygen forms?
O2 minus.
O2 minus. Again, if you are not able to remember this, you can go back to write the electronic configuration, remove, add 2 electrons, you will see that then only the octet will be satisfied. So eventually it is going to form O2 minus. Okay, so now this will come here, this will come here. So eventually you're going to see the formula as Fe2O3. Okay, so it is becoming ferric oxide. Now this is what is called as oxidation, but we will not go into this details. It is so much for your level. Okay, so basically ferrous sulfate, when you heat, you're going to form Fe2O3, SO2, and SO3. I told you either metal oxide will be formed, SO2 or SO3, or both of them can be formed depending on what metal sulfate you use. So if it is iron sulfate, ferrous sulfate, you will form both SO2 as well as SO3. Okay, this is basically a decomposition reaction. And they're asking, observe the color of the crystals. Observe the color of the crystals, and what do you think? Any guess? Color? Fe2O3. Okay, so I think I don't expect you to remember also. Fe2O3 will be colorless. Now that is white in color, or I can say it is white in color. Okay, FeSO4 will be green in color, and then when you heat it, it is going to become colorless. That is what is going to happen. Colorless means white in color. That is what is going to happen. That is the color change. So green becomes white is what you have to understand. Right? And then if you want to give more data, you can put 2 arrows here for this and this, telling that SO2 and SO3 are liberated as gases in the product side. That also you can do here. Okay, so you can see FeSO4.7H2O. We'll come to this, guys. What do you mean by this 7H2O and all to form? And the color of the crystal changes. It changes to basically white color. Okay, and then it decomposes to Fe2O3, and then sulfur trioxide, everything is there. Okay, now we'll spend some time on this, guys. What do you mean by this? So not only this, we write it a lot of time actually. We write it, say, we write like Na2SO4 dot 10H2O. We write CuSO4 dot 5H2O. Now in this case, you see FeSO4 dot 7H2O. Now what do you mean by all this? 5H2O dot 7H2O dot 10H2O. What do you mean by all this? Okay. Now all these water molecules which are there are what are called as water of crystallization. This is why crystallization. Okay, all these water molecules right after the salt, like this is the salt part, right? These are the salt part. After the salt, you put a dot and you write some number of water molecules, n number of water molecules. Okay, now that water molecules which are present are what are called as water of crystallization. Okay, now what is the science behind it? If you ask me, why do we write it like this? Now, please understand, people, when you form crystals, okay, fine. Now, let me tell you this, guys. Okay, let me ask you this question first, right? Say, I have taken a spoon of sugar. Okay, I have taken 1 spoon of sugar and I will dissolve it in water. I completely stir it. Okay, now tell me, is there any way by which I'll be able to get back the sugar crystals? Get back the sugar, whatever you obviously you will see sugar in the form of crystals. Right, it will be normal, very good shaped crystals, normal, very, very minute crystals will be there. Right, when you dissolve in water, nothing you'll see, colorless solution. The question is, will I be able to get back the crystal form, the sugar crystals? Will I be able to get back from this particular solution? Is there any way we can do that? Is there any way? Did you understand my question, guys?
By heating.
Okay, by heating, fine. What will happen?
Sir, the water will get evaporated and the sugar crystal deposit.
Correct. So that's what we do. That process is what is called as crystallization. Right. So basically the process of converting a solution in the solution form to its crystals is what is called as crystallization. Actually, again, you will do this experiment also in your 10th class. Please remember, please hope, please pray that you have to go to school. Not because you want to meet friends, but you have to go and see all this, whatever you're studying in the theory part, you have to go do it in the lab and see. Then only you can get the full satisfaction of learning it. Okay, so you'll study about how to make crystals in the labs. Okay, very small process. You will heat it, you will cool it, and then, or if I can tell you the process very simply, right? Say I will have the solution with me, okay, and I'll be heating it. Okay, say assume that this is sugar solution. Okay, I'll be heating it. Say I had some amount of water till here. I will heat it till the water becomes here. Very, very small amount of water is only left. Okay, very, very small amount of water is only left. And then what you do is you stop heating. Right now you have the sugar, the sugar solution with very less amount of water, and you have to cool it down. Cool down. Okay. Now after some 10 minutes or 15 minutes, you see, right? Now, if this is the thing, you will find that at the bottom of the vessel, you will find that the crystals has formed. Right? At the bottom of the thing, you will see that the crystal has formed. So again, what you have still the liquid present. Okay. So what you have to do is you have to tilt this towards this way. You have to tilt it like this so that the water molecules alone fall down. Right? The water molecules alone come out. Whatever the excess liquid which I have is there, that alone is going to come down. And that liquid is coming out is what is called as your mother liquor. Right? M-O-T-H-E-R, mother, L-I-Q-U-R, mother liquor. Mother liquor is basically whatever is the excess liquid which is there, you pour it down. Okay. That is what is called as mother liquor. Okay, anyways, now you would have, now in this test tube, now you will have only the crystal part. Okay, now this will not be in exact shape as you wanted it to be. So what you do is you take it in the filter paper, right? You pour it in the filter paper and you nicely press it. Okay, I hope you're looking at my video. Okay, so first thing is you will heat the solution. You will make sure that the water level is very less. After that, you start cooling it down. Cooling it down is basically, if you want to cool it, you can put an ice thing into a freezer, but the crystallization will not happen properly. If you want to have the crystals to be very perfectly shaped, you have to cool down it very slowly. Then only the crystal formation will be very good. Anyways, right. So you will, once you form the crystals, and when you cool down, after some 10-15 minutes, you will see that the crystals are settling down at the bottom. Right. So now what do? You slowly tilt it so that only the water molecules, excess water molecules, so this is coming out, and that excess water molecule is what is called as your mother liquor. Okay, now you will have the only crystals in your tube, in your vessel. So what you do is you transfer it to a filter paper. Assume that my hand is my filter paper. Okay, so in this filter paper, you close the filter paper and you press it nicely. Now why are we pressing it? Is because I want to remove still more water molecules. Okay, when you press it, you will remove still more water molecules, and then you put it in a china dish. China dish is like basically like this. It will be a dish like this. Okay, so you put it in a china dish and you keep it aside. Right. So after some half an hour, you will see that you would have formed beautifully shaped crystals. Okay, you would have formed beautifully shaped crystals, and this entire process is what is called as crystallization. Okay,
So,
right. Yeah.
so like we would have taken sugar, right? Like for heating. So after heating also, will the composition of the sugar be the same or it will change?
No, it won't change. It won't change. Right. Basically, again, it depends on the temperature. If you are going to heat it too much, right, very high temperature, then it may be chances that the sugar will get disintegrated. Decomposition reaction can happen. So basically, sugar is nothing but glucose. Glucose is C6H12O6, right? So maybe when you heat it, maybe you will form carbon dioxide in water. But again, for this, I require very high temperature, right? Normally, if you just normally heat it, nothing will happen, right? But if it is going to be too much heating, then it will disintegrate. Yes, the chemical composition will change. Okay, right. Good question. Good question. Right. So why did we start about all this? Is about studying about this particular part. What is this water of crystallization? Now we understood what is this crystallization process. I just explained you: heating, cooling, transferring, and then isolating. Right. You will form the crystals. Right. So guys, whenever you form the crystals, right? Whenever you form the crystals, say for example, copper sulfate. Now remember, copper sulfate, this will be blue in color. Right, this copper sulfate solution also you take copper sulfate salt, you put it in water, mix it, the solution will be blue in color. Okay, so anyways, now this will be the solid state, like this will be in the solid state. All of these are solid state. These are not aqueous solutions, people, right? These are all solids. All of them, whatever I mentioned here, are solids only. What is the time? Oh, I am not. Oh, I have actually exceeded the time. Okay, just give me 2 more minutes, right? Okay, fine, cool. So like you will see that all of them will be in the solid state. Okay, right. So this water molecule, I told you how much ever you remove, right? How much ever water molecules you remove, some of the water molecules will still be there along with the crystal. Okay, now why is it that I'm writing it like this? Why am I not writing Na2SO4 plus H2O or CuSO4 plus H2O? Why am I not writing it? Is because remember that water molecule is very, 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 very small. Okay, water molecule is so small. Two hydrogen atom, one oxygen atom. That's it. Very small molecule. But if you look at these crystals, right? Na2SO4, CuSO4, FeSO4, they will be very, very big crystals. Okay, now into these crystals, this water molecules will go and occupy some space. Right, into this crystal, this water molecules go inside the crystal and occupy some space. Okay, that water molecule, why is it going to happen? Why is it happening? Because water molecule is very small, but the crystal is very big. The size of the crystal, size of this shape, Na2SO4 or CuSO4 is very big. Okay, so whenever you form the crystal, there'll always be some empty spaces. Okay, so to these empty spaces, this water molecules will go and sit there. Okay, so for one molecule of Na2SO4, I find that 10 molecules of H2O are basically going inside, right? And that water molecule going inside and sitting in the empty spaces is what is called as your water of crystallization. Okay, so in simple words, crystal is so big, right, that you will have empty spaces inside the crystal. So into these empty spaces, water molecules will go and sit. And this is what is called as your water of crystallization. And this has very, very huge roles to play that we'll see in the next class, right? So basically, one example I can give you, I told you that CuSO4.5H2 will be blue in color. Okay, now when you heat it, when you remove the water molecule, that is when you have only CuSO4, this will become colorless, right? This will become colorless, like a lot of stuff, right? Why is it happening? We'll see tomorrow. We'll see next class. Okay, we still have the activities left, and we will spend some time on this water crystallization tomorrow. Next class. Is there any questions, people? Is there any questions? I hope. No questions. What is the composition of? Oh, this question was only asked. Okay, cool. Right. Okay, guys. Thank you so much. We'll again meet next time. Yeah. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.